Welcome to class. So we are starting right away. So today's class is about the networking basics, the basics of computer networking. So we are going to discuss first networking components. We are going to learn networking concepts, which include networking components and types, network protocols, standards and services, network devices, network cables. So those are the aspects that we're going to touch. So moving on to the first part, types of networks. We have different types of networks and then different devices used in each network. Some of the devices used include switch. When we say switch, we are talking about network switch. It's not the ordinary switch that we use to turn on lights in our house. We also talk about a router. We talk about access points, then we talk about wireless router, then modem. Then when we talk about network media icons, we have LAN, it's represented by a straight line. We have WAN, represented by a zigzag line. Then wireless media, represented by curvy lines. The network cloud, you see a symbol of cloud on that one. Then host devices include desktop computer, laptop computer, server, tablet, smartphone, printer, camera, IP phone, and then scanner. All these are hosts. They are different devices that can be connected into the network to communicate with other devices on the network. So they are generally referred to as hosts. Then we have network topologies. First one is PAN, Personal Area Network. This one commonly uses Bluetooth to connect devices such as mouse, keyboards, phones, and tablets. When you use your Bluetooth to connect to other devices, you have actually created what we call Personal Area Network. That is PAN. Then we have Local Area Network, LAN. This is a wireless network that consists of a switch, that is network switch, and some network devices in a limited geographical area. So the devices must be in the same location. They are not far away from one another. Then we have VLAN, that is virtual LAN. Virtual LAN extends beyond traditional LAN. And then what happens with a virtual LAN is that it extends the users beyond a small location, beyond just one location. You can have all of them in different, for instance, different levels in a building, whether you have a two-story building and you have on each floor, you have, let's say, 15 offices or 20 offices or 30 offices. Each floor can be connected through a LAN, but all of them will be connected together in a VLAN, the virtual LAN. We combine all of them together. Then we have the next one, WLAN, wireless LAN. Wireless LAN connects multiple wireless devices and uses access points to link them together. All right. Now, other topologies include WMN, wireless mesh network, which connects multiple wireless access points together to expand the wireless network. Then we have the MAN, metropolitan area network, a network that spans maybe an entire city that goes across all, connections in a particular city. That one can be called a metropolitan area network. Then we have WAN. WAN is wide area network. That's a network that spans a large geographical area. Now, when you look at man can be only in a particular city. Maybe, for instance, you can talk about Abeokuta. All the banks in Abeokuta can be connected together in a man. Now, a WAN goes beyond a small geographical area, goes to large geographical area. For instance, the whole state in southwestern Nigeria can be on a WAN, a wide area network. So that's the difference between the MAN and then the WAN. All right, WAN goes beyond a small geographical location. They extend to very large geographical location. All right. Then the next one is VPN, Virtual Private Network. It's a method of connecting devices together such that uh, in a company and then they have network across unsecure network. It's connecting devices together to a network such as a company network across an unsecure network. It's called a VPN. Now, apart from the network type of network topologies, we also want to talk about history of connection of technologies. History of connection of technologies. We have, in those days, analog telephone access that they call dial-up. That one uses a modem, analog modem to call another modem. That was in the early days of networking. They used that system. Then we have ISDN, which is Integrated Services Digital Network. That one has more bandwidth than dial-up, and then you can carry both voice, video, you can also carry data. So ISDN has more bandwidth and can carry your voice, video, and data. Now, the latest one is the broadband. Broadband uses different frequencies to send multiple signals over media. So it can carry both voice, data, video and the rest. But why they call it broadband is because that word band is referring to frequency. So when they say broadband means there are so many frequencies inside the same signal and it's sending different signals through different frequencies within the same signal. And so it makes the work to be faster in sending and receiving to devices in the network. Then we have the DSL. We want to talk about the internet connection types, the way we connect together the devices on the network. We have the DSL, digital subscriber line. That's a technology that's always that uses phone lines. Voice and data are carried on different frequencies, and then it requires a filter on the port that connects to a phone. All right. We also have cable. Cable connection uses a cable modem to connect to a traditional cable TV network, and then it shares the same network with multiple subscribers. For some of you that might be aware, if you use a television network such as the DSTV, you can also connect network through the connection. That's a cable connection. You can use you can subscribe to their internet connection through the DSTV signal, and then you can begin to use it at home for browsing. Then we have the other one, the fiber optic connection. This is a high bandwidth connection that is used as backbone of networks for large enterprise environments, large data centers, and now in some homes and offices, we are now using it for internet connection. It's very fast, in connecting and transmitting signal from point to point. But the only thing is that the fiber optic cables that carry the signal, they are very, very expensive. Very, very expensive. Then we also have what we call line of sight wireless internet service. Line of sight means when you are connecting from a point to another point, and each of those points must be working on a straight line to link each other. Even though physically man may not be able to see the point to point, but each point must see each other. And for instance, when you are using this line of sight, there must be no obstruction. There must be no obstruction in between. So there must be clear paths. If there is an obstruction, for instance, maybe like a tall building, like a skyscraper, or a tall mountain in between, you can actually block the signal and prevent them from receiving. So, for instance, all these GSM network providers, they are using masts all around us. What they use is line of sight. Each mast will be able to see the other mast that is nearby and link together with it and send signal or receive signal from it. Apart from transmitting the signal to the locality, they also communicate with one another. The mast communicate with one another to transmit, the network from a particular locality to where you are sending the signal go to. Apart from the line of sight network, we also have satellite communication. The satellite connection is a broadband technology for remote areas. And then when you are using that, you will require a satellite dish. But this system is not a good, installation for time-sensitive applications like gaming, voice over internet protocol, that is VoIP, and video conferencing, because it can delay, the signal. The signal can be delayed, can, you know, be late. And so for that reason, when you are dealing with time-sensitive applications such as gaming, VoIP, and video conferencing, they may not work well. It may delay the signal from reaching, the desired point. Then we have the cellular connection. Cellular connection has to do with our, cellular network, such as the GSM network that we are using, the MTN, the Globacom, and the rest and the rest. They use cellular connection. And this one rely on cell towers. What they mean by cell towers here, they are the masts that we see all around us. That is where they install the radio signal, the antenna that is beaming out the signal and receiving it from different cell phone users. And then from there, we can use our cell phone to connect to it, from there to the internet. All right, that is a cellular connection. Apart from that, we also have the most recent advancements in connection types, that is the mobile hotspot and tethering. Mobile hotspot and tethering is available on a smartphone now. Maybe you are using Android, iPhone, Windows Phone, and so on and so forth. You can connect with other devices by means of your hotspot. And so when you do that, we call it tethering. What you do is that you enable your system, your phone or your device to carry out the signal, and then the other person will be able to connect using whether Wi-Fi, Bluetooth, or a USB cable. And then through that, a device that is not connected to the internet can actually be connected to the internet through the hotspot of another device. This system allows a cell phone that allows Wi-Fi devices to connect and use the mobile data network. It's actually the data network of your uh, network provider that you are using that you are also actually sharing to another person. Now let's go to the networking protocols. Networking protocol standards and services. So we're going to talk about the TCP/UDP in this section. The TCP/IP model. TCP/IP model is one protocol of the internet. The other one is the UDP. The TCP/IP model is having these properties. It's reliable. It acknowledges data. It resends a lost data and delivers data in sequential order. What they mean by it acknowledges data is that when signal is sent, there's going to be a confirmation to the sender through the network that the signal has been received. And when such is not received, that acknowledgement is not received, it means probably that the data has lost. Then the system will resend that data, and then the data are being delivered in a sequential order. On the other hand, UDP is another protocol. It's a little bit different from the TCP/IP. It's fast in operation. It has low overhead. It does not require acknowledgement. It doesn't acknowledge whether the data has been received or not, and does not resend any lost data, and delivers data as it arrives, one after the other. All right. Now, the TCP layer has three basic operations of reliability. It has numbering and tracking of data segments. It acknowledges received data and retransmit any unacknowledged data, like I've explained before. Then the UDP has very little overhead, as I've explained, and it's a best effort delivery protocol, but not reliable. It's not that reliable because it doesn't give any acknowledgement whether the data is received or not. So when the data is lost and it's not received at the destination, you may not get that data because it will not retransmit it. So that's the disadvantage of the UDP, right? The next one is a classification of port numbers. You want to classify port numbers of a internet connection. We have the ports, their numbers, then the protocol name, the application protocol, and the description. We have a port 53, which is used by TCP and UDP, and the application protocol is DNS. Port 80 is used by TCP only. Application protocol is HTTP. Port 443, TCP and UDP utilizes that, and it is HTTPS. HTTPS here means that there's an encryption system, kind of security system on the network on that one. Then we have email and identity management protocols. Port 25 used by TCP, and the application protocol is SMTP. Port 110 is TCP, and the application protocol is POP3, POP3. Then port 143 is for transport protocol, and application protocol is IMAP. Port 389, TCP, UDP, both of them utilize that. And then application protocol is LDAP. So then we also have a remote access protocols. Port 22 is used for TCP, and the protocol application protocol is SSH. Then port 23 for TCP also, application protocol is Telnet. Then port 3389, TCP and UDP, and then application protocol is a RDP. Okay, so these port numbers are assigned to different protocols and application in the network environment. So when you see sometimes on your phone, you see the networking data, you see some of these items there. So you should be able to at least understand or have an idea of what they indicate. They indicate protocols. Then wireless protocol. We have wireless protocol, WLAN, WLAN. It is designed by the organization IEEE, and they gave different standards. The first one is the 802.11a, which operating at a maximum speed of 54 megabits per second, and the range where it can connect devices is about 115 feet or 35 meters. The frequency of operation is 5 gigahertz. Now, after about 115 feet, then the signal will be lost. It will not be able to connect any device. Another one is a 802.11b, which operates at 11 megabytes per second. It also covers the same distance, 115 feet, but the operating frequency is 2.4 gigahertz. And 802.11g, the maximum speed is 54 megabits per second, and the maximum floor, distance that it can cover is 125 feet, about 38 meters, and operating at 2.4 gigahertz. Now, this one is compatible with a 802.11b. Then 802.11n, operating at a maximum speed of 600 megabits per second, and then the range it can cover is about 230 feet. That's 70 meters. And the frequency is at a 2.4 gigahertz and also 5 gigahertz. They are compatible with 802.11a, b, and g. And 802.11ac is operating maximum speed is 1.3 gigabits per second. That is 1,300 megabits per second. That's very fast. And the distance it can cover is 115 feet. That's about 35 meters. And operating frequency is 5 gigahertz. It's compatible with only 802.11a and n. These protocols, they are the device that is built to send wireless signals from our devices, such as laptop, tablet, phone, and the rest. These are the devices that send out wireless signal that we use, to connect to wireless network. And these are the range of the distance that they can cover as specified by the organization, that is IEEE. All right. Now we also have different wireless connections such as Bluetooth, NFC, and RFID. Bluetooth, we all know Bluetooth. We use it to connect devices, and that is when you set up that, we call it PAN, personal area personal area network. Then you can connect up to 7 devices to create a PAN. It's operating with 802.15.1 protocol, and then the operating frequency is between 2.4 to 2.485 gigahertz radio frequency. The RFID is a passive or active tag, uses a passive or active tag to identify items. The passive rely on RFID reader. Active uses a battery to broadcast the ID up to 100 meters. And operating frequency is 125 megahertz to 960 megahertz radio frequency range. Near field communication. When you use near field communication, the devices must be close to each other. So you see some devices, maybe at supermarket, that they use something to scan a code. They are using NFC, near field communication. And then you see that before they can scan, they will move it closer to where they want to scan. It's used for payments, printing, public parking, etc. Those are the things they use this kind of a protocol, to work with. It's also part of wireless network. Then we have ZigBee and Z-Wave. ZigBee and Z-Wave, they are also using IEEE, 802.15 standard, can connect several devices up to 20 meters. That is ZigBee. ZigBee can connect several devices up to 20 meters. About 65,000 devices can be connected. And then the speed, of transmission will be about 250 kilobits per second. Then Z-Wave uses proprietary standard, and then there's another version which is public version. You can connect to around 32 devices only using a mesh network, and the data speed is about 100 kilobits per second. Then in wireless protocols also, we talk about cellular generation. That is generation of the phone system that we use, called a cellular generation. The first cellular generation is 1G. 1G and 2G, they came together like first generation, and they use analog calls only. And then 2G introduced digital voice. 2G introduced digital voice, conference call, and caller ID. And then the speed was less than 9.6 kilobits per second. Now, they upgraded that one to 2.5G. 2.5G now was used for, apart from making call, conference call, and the rest, it can also be used to browse the internet, web browsing, short audio and video clips with speed up to 237 kilobits per second. So at that time when we were using all these ones, the internet was very slow. When you click a video, a small video, it will roll and buffer and buffer. It will show you like 10 seconds, then begin to buffer again, like 30 seconds again, show you another 5 seconds, and so on and so forth, because the speed was very low. Then 3G was introduced. 3G supports full motion video and streaming of music, and the speed is up to 2 megabytes per second, meaning that it's considerably fast. So when you have 3G, you can enjoy video streaming of music on the internet because the speed is up to 2 megabytes per second. Later on, they move on to 4G that we now have. 4G uses IPv6, and then it can support IP-based voice, gaming services, high-quality multimedia at speeds of up to 672 megabits per second. Then we have the LTE. LTE is about 4.5G, kind of long-term evolution. That one is operating up to the speed of 4G, and then improves connectivity while in motion. So when you are in a vehicle and you have LTE network, you are using it on your device, then your device can still connect, conveniently, because it supports motion. So the speed is up to 100 megabits per second when you are using it on mobile, and when you are using it, that is when you are driving a car, the speed will be operating at 100 megabits per second. But when you are stationary, the speed can go up to 1 gigabit per second, and that means it's going to be very, very fast, going to show video very fast, upload very fast, and so on and so forth. Then 5G. 5G is the latest one, and that one supports augmented reality, virtual reality, smart homes, smart cars, data transfer between devices, and the download speed of this 5G is up to 3 gigabytes per second. It means if you have a video of 1.5 gig in less than 1 second, it will be downloaded onto your device if you have a 5G device. So you can see that this is very, very fast. Then upload speed is up to 1.5 gigabits per second. Now, 1.5 gigabytes per second means even if you have a video of 1 gig, within less than 1 second, it should be uploaded if both devices are operating at 5G. So that is the advantage of 5G. It's going to be very, very fast, supports a lot of work, including some of the advanced work in the world today, like operation. A doctor can be in the United States and then be operating a patient through a robot via the internet here in Ilaro if 5G is available. So those are some of the advantages of the 5G technology. Of course, it exists in few places around the world. It's only 4G and LTE that are now being used very well everywhere. So that is about the technology, generations of the technology. All right. Okay. So I hope you are hearing me. So if you are hearing me, let me see yes. You can type yes into the chat box. Okay. So I just asked you a question. Are you hearing me well? So if you are hearing me well, just say yes. Let me see you type yes. All right. And then if you don't hear me, let us say no. If you don't hear me, probably network is poor. You can say no. Let us see you. Okay. So we want to continue the discussion. We have just discussed the generation of the cellular generation, that is GSM generation from 1G, 2G, 2.5G, 3G, 4G, LTE, and 5G. So those are the generations that we have. Then now we want to talk about network services. Client server rules. We have file client and server, web client and server, email client and server. When you go through the the modules, you learn more about all these different aspects. When you have a network connected, you have a kind of a connecting device like a switch that link up devices, connecting web clients, file server, web server, email clients. All of them can be linked together by means of a network switch. A network switch can be the man in between that can communicate from all these different devices one to another. All right. Then we have DHCP server. DHCP server is the device inside a network that provides IP addressing information. What do we mean by IP addressing? Internet protocol addressing. That is, each device that communicates on the internet has a number through which it can link the internet. The number is assigned to each device, and every device that is going to communicate on the internet or on the network, we have the IP address. It's a series of number or probably numbers with alphabets. So the device that issues those numbers to different devices that give them the access by means of the number is called a DHCP server. That's the one that is addressing the IP address to different devices on the network. DHCP server. All right. Then we have DNS server. DNS server is the one that translates domain names. For instance, if you say netaka.com or cisco.com, that domain name actually has one IP address. So for the network to understand, when you type cisco.com, the network does not understand cisco.com. But there's a device on the network that will actually convert that one to IP address so that the network will now know which website you are going, because each website have been saved with an IP address. So a DNS server is the one that translates the name, the normal name that you type as a user onto your system when you want to browse the internet into the IP address number. So the device is called DNS server. DNS server. Now we also have a print server. It's another service that is provided on a network whereby many printers can be controlled on the same network. And this print server provides client access to print resources, allows centralized print job administration, whereby it can be controlled maybe from the server room, and then it provides feedback to network clients. So the device that does that is called a print server. Then we also have file server. A file server allows clients to access files using a specific protocol. So there could be different protocols used on a network such as FTP, File Transfer Protocol, FTPS, File Transfer Protocol Secure, then SFTP, Secure Share File Transfer Protocol, and then SCP, Secure Copy. These are different protocols by which the file server, allow access to files on a network. Now, I can see that many of you are saying, yes, that's fine. Now, don't forget to click like to this video, click on the thumb up button, and then subscribe to the channel. Don't forget to click subscribe. Some of you have not subscribed to the channel. Click subscribe to the channel. All right, let everybody do that so that another time when we are going to bring the lecture up, you'll be notified when we are going to start it. All right. We also have a web server. Web server is one that provides resources using the protocols that we have mentioned, which include Hypertext Transfer Protocol, HTTP, using port 80, TCP port 80. Then secure version of it is HTTPS, secure HTTPS, that is Secure Hypertext Transfer Protocol. So anytime you see HTTPS on a web address, you know that web address and website is secured. And the secure HTTP uses what we call secure socket layers, SSL. Those are the things that they use to secure it. Transport layer security, TLS, and then TCP port 443 is using TCP port 443, whereas HTTP uses TCP port 80. All right. Then we have mail server. These are another device on the network. That is the device that controls email, communication with email on the network. So it communicates with server in order to reach a different client. And then the protocol used to send email include a simple mail transfer protocol, SMTP. The protocol used to retrieve email is POP, Post Office Protocol. And then Internet Message Access Protocol, IMAP. Either of those two are the protocols used to retrieve email. To send email, SMTP protocol is used, but to receive it, POP protocol or IMAP protocol are being used to receive. Let's move on fast now because we are just about half of the lecture and I want to go a little bit fast so that we can end it without wasting much data. All right, we have proxy servers. Proxy servers are devices that act on behalf of their clients, then hiding the real name of the internet host. Okay, they use to cache frequently accessed web pages. Any frequently accessed web pages are, they use this proxy server to, to cage them in. Then we have authentication server. Authentication server, allows authentication, authorization, and accounting on a network, on a particular network. Then we have a syslog server. Syslog server is the one that stores network messages that were being sent by networking devices. Networking devices, they have a way of communicating and sending messages to one another. So the syslog server is the one that stores the information that the network devices are sending. All right. Now the next discussion is networking devices, basic networking devices. We want to talk about switches, routers, and the like. Here, some of the basic ones that we have discussed before, they include the network interface card, NIC. The network interface card is a part of the computer that you can install on the, expansion slots. We discussed the general term for all these cards. That is adapter cards. So the network interface card is the one that you use when you want to use a computer on a local area network, LAN. So the LAN cable will be plugged into it at the back of the system. Then we have the wireless NIC, wireless network interface card, that carries a small antenna. When it is installed onto the computer, the small antenna at the back is the one that will be receiving the signal wirelessly for the desktop. Then we also have USB NIC. That's a USB NIC that you can actually purchase, maybe from Globalcom, from MTN or Airtel, whereby it's like a USB and you plug it to your system and then it's receiving the network wirelessly for you. These are network interface cards. Then we also have repeaters, bridges, and hubs. Repeaters are called extenders because they regenerate the signal so it can be sent further. When you are sending signal on a network, it's limited for the signal you are sending through a cable. Maybe it's limited to about 100 meters. After about 100 meters, the signal will be degraded. It will not be clear on the network again. Then it will not be received at the other end. Maybe you are going to send to like let's say 200 meters. So you will need a repeater. Maybe after 100 meters, you use a repeater. It will now confirm the signal and boost it up again and regenerate it and send it again. Then a hub that receives data on one port, and when it receives that data on one port, it sends it out to all other available ports. The same data we send to them. So any device that needs that data will receive it and utilizes it. Others that don't need it, just drop it. Then we have a bridge. A bridge is a kind of a device that divides a network into two or more segments and then tracks which device is on each segment. We also have switches. Network switches is a device that connects several devices together, and when it receives a signal, it sends the signal to the device that is actually needing it. It will not send it to all devices like the hub. No, the switch send the signal received to a particular network device that actually needs it. It knows the network device that actually requires that signal, that data or information that is being received. And then Ethernet switches, they record MAC addresses for each device connected to the switch. The MAC address is the number or alphanumeric number that identifies each device on the network, like their name, like your name. Now, when you come to school, you have a name registered, then you also have a registration number. So MAC address is like the name of the device, where registration number is like the IP address of the device. All right. Now, managed switches can be used in a company environment and they have more features than simple switches. But managed switches can be used for small businesses on a small network. Okay. Then we also have wireless access points. that provide access to wireless network for a limited range. So those ones are called APs, wireless access points. They provide wireless access on a network for a limited range. Then we have the routers. Routers connect networks to other networks and they use IP address to forward traffic to other networks. So a router can forward the traffic from one network to another network through an IP address. It can also be a multi-purpose device, which is an integrated router. So if it's an integrated router, then it will have the capacity to be a switch, to also have a wireless, wireless router. Everything will be embedded inside the same device. That's a integrated router. It can be switch router, wireless router together inside one. Now we want to talk about firewalls. That's a security devices. A firewall is a system that protects data and devices connected to a network. And this uses access control lists, which is able to rule out or determine which data should be permitted, which data should not be permitted, that is, which data should be denied. So it's a software system that protects, network. When signals are coming from outside, it checks them whether they should be allowed to enter into the network or not. So that is what firewall does. It's a security means. So because some signals may, some communication may be, intruder, maybe from intruder that want to copy, private information, confidential information on the network. So a firewall can block them depending on the setting that you know, set for this firewall. Then security devices also include IDS and IPS. IDS is intrusion detection system, and that one monitor traffic as a passive system. And then IPS is intrusion prevention system. That one monitors traffic and takes action when needed. So when an intruder is coming, it checks and then it can block them. That is IPS. It takes action, can block intruder that we don't welcome on the network. But IDS just monitor the traffic. It cannot, it can only detect, it cannot block, take action by blocking the intrusion. We have UTMs. UTMs are universal threat management devices. Universal threat management device. So inside this universal threat management device, we have so many package. Inside it, we have firewall services, IDS, IPS services. We also have additional security against zero-day, denial of service, distributed denial of service, and spyware. We also have proxy and email filtering within the same device, network access control, and VPN services. So it's a all-encompassing device for security of the network. Then we have a endpoint management server. Endpoint management server monitor devices such as PCs, laptops, servers, tablets, printers. This is another security device. Then we have other network devices such as legacy and embedded systems. A legacy system is a device on the network that is no longer supported but still in operation. Still in operation but it's no longer supported. Whereas an embedded system is a device built into something such as an appliance, embedded microchips. They are contained in legacy system and embedded systems. Legacy systems and embedded systems could be a security risk because they may not be supported again by updating their software and the rest, but they are still in operation, so they can be security risk to a network. Then we have patch panel. That's a centralized place where cables are attached to the network devices and the network connection room especially. We call them patch panel. Other networking devices include power over Ethernet, Ethernet over power, PoE. So we have a PoE switch, that's a power over internet switch. It's an internet switch that has the functionality of power over internet, whereby it can provide to devices functions such as APs, camera, IP phones, by connecting to them through a cable. Then we can also have what we call a PoE injector. It can be connected to a cable, and the second cable is used to connect device that receives power from the injector. Then all these devices, they will need network cable, the Ethernet cable to link devices together. Then cloud-based network controller. There's a device called cloud-based network controller. Okay, cloud-based network controller. It's a device, a remote device that I use to manage network devices like access points or switches. All right. So gradually we are going to the end, little by little. Now we want to talk about the network cables. Network cables. Eh, Later on in our practical, we look at how to make network cables, but you need certain tools to do that, such as the tools that we need include network cable crimper, wire strippers, cable connectors, punch down tool, network cable tester, toner, and probe. So these are some of the tools that we need to make a network cable. Now, when you get to the module, you see the pictures of these devices, and then other devices that's also needed. The tools include wire cutters, wire strippers, crimper. You see how they look like. The crimper is used to, hold firmly the RJ45 connector to a LAN cable. Wire cutters to cut the wires, wire strippers to strip the insulation away from the wire. And the punch down tool is used to terminate wires, into a termination. We also have a network tools, other network tool like a multimeter that we can use to measure or test for continuity of wires, whether the wire is broken inside or not. So we can use that one. Also to test for voltage, whether there's voltage in the wire or not. Then we have tone generator that also tests, between devices by producing a tone. We have cable tester, we have Wi-Fi analyzer, and then we have a loop back adapter that is used to check a port. Then we have cables. We have different types of cables. Some of these cables have been mentioned in class. We have the twisted pair, the coaxial cable, the fiber optic cable. The twisted pair is the LAN cable that has 4 pairs, and each pair has two wires twisted together. If you untwist all these wires, we're going to have 8 wires. And 4 of them have single color, and 4 of them have two colors. The coaxial cable, we have explained that in class. It's a cable that has one straight copper wire inside and another wire that is made like a net, like a mesh around insulation on top of the first cable. Then we have the fiber optic cable. Fiber optic cable is designed as like a glass inside that carries the network signal like light. It carries the signal like in form of light, and is very fast, faster than any other type of cables. The coaxial cable, yes, it can be connected to TVs through a connector at the mouth. Then we also have twisted pair cables. I've explained this. Then we have UTP and STP of twisted pair cable. UTP is the unshielded twisted pair, and the STP is the shielded twisted pair. The unshielded twisted pair have all those follow 4 pair of wires inside, and then you can be affected by electromagnetic interference (EMI). It can be affected by EMI and radio frequency interference (RFI). That is why an STP cable is better. It has protection against EMI and RFI, but it's more expensive and then harder to install than the ordinary UTP. So STP cable can shield from interference from RFI or EMI, but it's much more expensive. Then twisted pair cable categories. We have Cat5 UTP. It can carry signal up to 100 megabit per second at 100 megahertz. Cat5e, 1 gigabit per second at 100 megahertz. Then we have a Cat6a, 1 gigabit per second at 250 megahertz. These are the properties of these different types of cables. We also talk about twisted pair wire schemes. We have T568A, T568B. Those are the way the cables are arranged at the end into the connector. So we have two different types of arrangements. And the color labels, the way you arrange them will determine the type of cable you are making, whether you are making a straight through cable or a crossover cable. So in the practical, we practicalize this. We do it practically how to make a straight through cable and a crossover cable. The straight through cable is used to connect, two different devices, like a laptop to a printer, a laptop to a switch, a laptop or a desktop to a router, and so on. You need a straight through cable. And a crossover cable is needed when we are connecting the same type of devices together. For instance, you want to link a switch to another switch, you will need a crossover cable. So how to design that will be made clear when we carry out the practical in class. All right. So fiber optic cable, like I said, uses light to transmit signals, and then it's not affected by EMI or RFI. Electromagnetic interference and radio frequency interference does not affect you know, the signal inside the fiber optic cable. There are two types of fiber optic cables. We have the single mode fiber and then multiple mode fiber. Single mode fiber has a small core and using laser technology like a beam of light that sends signals through long distances. The multi-mode fiber uses a very large core. The inside core is larger and then uses LEDs to send lights, and the light is injected at different angles. It's cheaper, and then the bandwidth is up to 10 gigabit per second or up to 550 meters. You can send signal for up to 550 meters. All right, then we have fiber optic connectors, SC connectors, LC connector, and duplex multimode LC connectors. So those are different types of connectors on the fiber optic. ST connector, you see this in the module, SC connectors, then LC connector, and duplex multimode LC connectors. So these are different types of the module. So with that, I have come to the end of the chapter. I've come to the end of the chapter, so I encourage you to check the modules and read. At the end of the chapter, there are so many acronyms, terms that were mentioned. So they are listed at the end of the the module. All right. So I want to encourage you to please log on to the course online and read. Now, I don't know whether anybody has a question. Can you hear me, please? Let me see your comments. If you can hear me, let me see your comments. So somebody say I should one firewall, can the printer be connected to it? Please, sir, if one disable the firewall, can the printer be connected to it? No, the firewall is not inside the printer. The firewall is a system by which a software system by which a computer can be protected from intrusion. When signals, outside signals are coming in, the firewall will check whether this data that is coming in, whether it should be allowed to enter into the system, to the network of the system or not. So that is about firewall. Now, firewall disable does not affect a printer. A printer can still be connected because what the printer uses to link with the system is called a driver, printer driver. So that one is not affected by the firewall. Okay, so that is it. Now, Deronke Fumilayo said I should recap. I don't know the aspect you want me to recap, I don't know the aspects. I don't know. So somebody said I am too fast anyway. That's true because I don't want you people to stay too long on the lecture because of data. We are all using data. I'm using, you're also using. So that's why, so bear with me. But the thing is, you can watch the video again. I will make the link to the video available shortly after the class. I will go online and copy the link because immediately we stop this class, YouTube will compile the video and save it onto the channel, and so we can actually go back and rewatch it. So that is the beauty of the whole thing. I will make the link to the video available to you people. All right, so I can see that everybody can hear me. So I don't know whether there are still more questions. If you have any question, network tools. Okay, somebody asked about network tools. That's good. That's a good question. I made mention of network tools that are needed in making a network cable. I made mention some of these network tools such as the crimper. Remember crimper? I made mention of the wire cutters. I made mention of wire strippers. I made mention punch down tool. I made mention of network cable tester. We call it LAN tester. LAN tester. I made mention of tone and probe, I made mention of a multimeter. Multimeter. You will see some of these devices when we go to the practical class. You will see when we want to make the cables, and when we finish making the cables, we use these tools, Then other network tools also, we call one loop back adapter. We call another one Wi-Fi analyzer. Wi-Fi analyzer, you know. So these are different types of, uh, uh, networking tools that we use to make network cables and to also test, networking devices. All right, so you see what I'm posting onto the chat now. I have posted the names of these devices. I'm posting the name of the devices so that you can see all devices that I mentioned. Okay, so you can see the name of the devices on the chat box. Let me also copy more of them so that you can see the name of the devices and what we use some of them for. It's also written there. Okay, so you can see wire cutters, wire strippers, and what we use some of them for. Okay, then we have the punch down tool. So you see them there in the charts. Port numbers, well, port numbers is somebody is asking about classification of port numbers. Port numbers, they are used to identify different network connection. There are different ports for instance, email, different ports for the network protocol TCP/IP, the UDP, they use different ports. Email system, POP3, IMAP, they use different ports. Now the ports are necessary because when the signals are coming, they enter through the system via these ports. So the system has been designed, the network has been designed that when signals are coming, if it's TCP/IP, this port should be used. If it is UDP signal, it must use this port. So different ports for different data that are coming into a network or to a system. So that is about the ports. So we have different numbers on the networking ports. We have port 80, port 88, port 143, port and so on and so forth. So different ports for different, you know, data received or being sent. Okay, that's about the ports. So thank you very much. We have almost spent 1 hour here. So I want to say let's call it a day now because it's night already, and so we need to call it a day. Meanwhile, I'm going to provide the link to the video after we end the class now, so that you can actually you know log on and watch the video again and listen to the explanation. All right. So can I say bye bye to you all now? All right. So let me see your bye bye too. Let me see your bye bye. All right. Thank you for joining the class. Thank you for thanking me also. All right. So I hope you are enjoying the break at home. So please be careful with the time that we have now. So I'm ending the class now. Okay. Okay. Thank you too.